Right, dimensions. Here, we just asked to figure out the dimensions for each of these different properties. Capacity of a jug, basically how much you can fill in the jug. Okay, so the volume, if you like, of a jug, how much water you can put in or whatever, with the space in it. And of course, we've got three dimensions. Because if you remember, with volume, we usually do, don't we, length times width times height. Okay, we usually think of it that way. There's three dimensions there, yeah? There's a length, there's a width, there's a height. Okay, so that gives you how much space, and that's true of a jug, how much space is in there to fill it with water. Okay, so you sometimes use that word capacity to show how much you can fill in there. Circumference of a circle, and with the circumference, it's actually just measuring the length around. Okay, right, that's all you're doing with a circumference. You're measuring the length around, so you end up with a length. Okay, right, which is just one dimension, isn't it? All right, one dimension. That's all it is. Volume of a cuboid. Okay, again, you get that idea, right? You times in length, width by height. So there's three dimensions there. Distance between Cardiff and Biltwells. Well, you're just measuring the distance. You're measuring a length. Okay, even though, you know, if you were to measure by the road, you'd be changing directions. You're still measuring a length. Here, I suppose, though, the distance from Cardiff and Biltwells is the direct distance that sort of a crow would fly. So it's even easier to think that it's just going to be a single length. It's just one dimension. Area of a rectangle. If you think about a rectangle, you would do length times width, isn't it? Two dimensions. Okay. Now you get these type of questions as well, right? And they ask you what could these sort of formulas be used for? Okay. Area, length. We've got length, area, volume, or actually none of them. Maybe that's the case, where these formulas wouldn't be used for any of them. Now, don't get put off with these, right? Basically, they're introducing letters here, but you could think of AB as like a length times a width, okay? So in that case there, that would give you an area, wouldn't it? Okay. The fact that it's been doubled doesn't make any difference, you know, because if you double it, it's still an area. So when it comes to this question, we simply ignore the numbers, right? Just ignore them, right? They're not important. You can cross them off. But here you could see that AB is like a length times a length, isn't it? Yeah. So we end up with an area, and of course c squared. Well, again, c squared is just c times c, isn't it? So again, that's like a length times a length. That would give you an area, wouldn't it? So an area plus an area just gives you an area. Okay. So, you know, in this case here, we're just interested in what the formula represents, right? And this here quite clearly is an area, you know, and we might be adding them together, but it just gives us an even bigger area. Here, again, right, we've got 4a plus 3b minus c, okay? Your a represents a length, doesn't it? Okay, right? A represents a length. Okay, they haven't necessarily called it L. Doesn't matter though, doesn't it? Doesn't matter what letter they used, it's a length. The fact that there's 4 in front of it just means that it's been multiplied by 4, so the length has got 4 times longer. It doesn't make any difference, it's still a length. So as I said, ignore the numbers, right? Ignore them, don't worry about it. You've got a length here, and we're adding it to B, which is just another length, isn't it? And then we're taking away a length. At the end of the day, we're going to end up with a length, aren't we? Because we're doing a length plus a length, which is much bigger, and then you've taken away another length. So we still end up with a length, okay? That's what that formula could represent there. Here, as I said, ignore the numbers. AB squared, think about what's going on here. We're multiplying together. We're doing, A is representing a length. Think of what B squared represents. B squared. B squared is just B times B, isn't it? And we saw earlier on, and that would be like an area, wouldn't it? It's like an area of a square, if you want. If you think about a square of length B, okay, B squared then would be just B times B. You times them together, so it gives you an area. But if you're timing it by another length as well, A, think about what we end up with. It's a bit like that idea up here, isn't it, with the volume. length times width times height, you're timesing 3 dimensions together. And that's the case here. You're timesing 3 dimensions together. You're doing A times B times B. So we have a volume. Now we get to a case where actually it doesn't actually make any sense, because if you look here, AB, think about what that represents. AB, of course, represents an area, doesn't it? Yeah? It's like an area, because it's 2 dimensions times together. C cubed, well, that's a volume, isn't it? Because you're timesing C by itself 3 times. C times C times C. So what you're doing here is you're adding an area and a volume, and that doesn't make any sense. You know, if you think about it, if area represents something flat, volume has got space to it, adding them doesn't make any sense at all. So the formula represents nothing, basically. Okay, none of these. It doesn't represent length, area, or volume. The last one then here, okay. Again, if you think here, right, we've got A plus 2B, right? A represents a length, doesn't it? Yeah. 2B, well, again, don't worry about the 2, right? You know, it just means that B is a length, isn't it? So if you've got 2B, it's just an even bigger length. It doesn't make any difference. But if you think in that bracket now, if I add them together, A plus B, I've just got an even bigger length, haven't I? Even bigger length. So you've got a big length, and then because there's a bracket, you're timesing, and you're timesing it by C, so you've got a length. Big length there. When you add them together, you're timesing it by another dimension. So this is a bit really like length times width, isn't it? If you think about it, because all of that becomes a length. Think of that as a width. Length times width. Of course, is area. Okay. Right. In this case here, now let's look at another situation where they ask the same sort of thing. The first one's been done. You can see why it's an area, can't you? Because r squared is an area. DH is also an area. Right? So you're adding 2 areas together. If you add 2 areas together, it just gives you an even bigger area. Let's look at this idea of a bracket again. You've got 2D. Well, remember, D is a length. Twice that length is just even bigger length. As I said, ignore the numbers. So you've got a length then, and H is a length. So if you've got a length, take away a length, you're still going to end up with a length, right? You know, this is a different length, isn't it, to this one. So you end up with a length here. That bracket becomes a length. R squared, well, remember, that represents R times R, right? So that's like an area, isn't it? Okay. Which you could think of it like as L squared. Think of it that way. Right, as an area. So then if you've got an L squared out here, an area timesing by length, if you think about it, an L squared times another length will give you like 3 dimensions, won't it? You've got 2 dimensions out here, 3 dimensions, so we end up with a volume. Okay, here again, ignore the numbers, but that's a length, isn't it? That's a length. That's a length. So adding the 2 lengths together, taking away a length, you still end up with a length. Here, what do you think that represents? It's just a length, isn't it? What does this represent? Again, ignore the numbers, yeah? Ignore the numbers. dr. Well, dr is an area, isn't it? Because it's d times r. And here, 2d. Ignore the 2. D is just a length. So you've got this, lal, length, area, length. It doesn't make any sense. You can't add a length and area together, so it doesn't make any sense. There's none of these. Last one, RD. RD, of course, area, yeah? D squared, area. HR, area. Area, take away area, add area. They're all areas, aren't they? They're all areas, so it represents an area. Okay?